Good morning, everyone. I welcome you all to this session on Introduction to Generative AI, Module 5, with reference to a non-technical introduction to Generative AI. Here in this module, we're going to see the concepts of probability with respect to Generative AI and also some of the type of Generative AI, especially the GAN is what we're trying to see in a largest prospect. So the content of today's session would be how we understand the discriminative and the generative model. We have seen in the last session how the discriminative model differs from a generative model. Here in this, we are trying to see with respect to the concept of probability. The type of generative AI models available, and out of this, we will pull out GAN, Generative Advisory Network at a high level as an overview. Then we'll start understanding the different GAN architectures and challenges faced by GAN. So the discriminator and the generator models with respect to probability, first let's just understand what discriminative model uses. They use basic probability. When I say basic probability, we are trying to understand the relation between the input and output. The correlation between output and input is what we basically find using basic probability. Why? Because we are trying to predict with respect to input. In a generative model where we are trying to create new things, we use four concepts. The first one is the conditional probability, joint probability, sample space, and PDF, probability density function. The first one, conditional probability, this is in sync with the basic probability. We are trying to understand the relation, the correlation between the input and output. The second one is joint probability. That means the probability of two or more events happening at the same time. Understanding the likelihood of multiple events occurring together. That's what we try to understand with joint probability in the generative models. The third one is a sample space. Here, all possible outcomes of an input facilitated. For example, if I have to take an example of tossing a coin, we would find all the possible results of the tossing a coin would be head and tail. So the sample space would have head and tail. If I have to roll a die, a six-sided die, so it would have all the possible six sides, 1, 2, 3, 4, 5, and 6 are the sample space. Then we have what is called as the PDF, which is an algorithm. Probability density function is an algorithm, and this helps understand the probability of the events happening in this particular sample space, which has different values. Now, the type of generative model, we have four of those. The first one is a transformer. Then second one is the GAN, Generative Advisory Network. The third one is VAE, Variational Autoencoders, and fourth is a diffusion model. We'll start understanding each of these, but in this particular module, we will understand what GAN is, Generative Advisory Network is at a high level. When I say Generative Advisory Network, GAN, what are they used for? Basically, we know that GAN is it's a type of generative network, generative artificial intelligence. So it is to generate something new. And what are we trying to generate here using GAN? We're trying to generate unique, realistic images. It could be videos and it could be illustrations. Let's understand the GAN model or a GAN architecture at a higher level. This GAN architecture is made up of two neural networks. So neural network number one and neural network number two. And both of these neural networks are basically CNN, convolutional neural networks. So the first one, the neural network, which is also called as the generator network, and the second one is called as the discriminator network. What does the generator network do? It tries to, get in data, or the injected data, is the real data, which is the photo or the image, which gets into the generated network, gets it tries to create, or it tries to create fake images, which is also called as noise. So basically the generator is trying to convert the real data into a fake data. And the discriminator on the other side, here we are trying to understand this particular discriminator is trying to differentiate what is the fake and what is the real. Okay, and how do we do that? This can be better done by using appropriate loss functions. There are a couple of loss functions. For the simplicity, I've jotted down four main loss functions. Min-max loss functions we have, Wasserstein loss function, and then cross entropy loss functions. So basically here the discriminator and the generator, these two models interact in an advisory way. So that it's like a conflict way. The generator is trying to produce fake images out of the true image, and the discriminant is trying to differentiate, hey, this is what the fake you have produced. Yeah. So let's understand how these models work in the initial stages, which is good to know. When we are in the training stage of this particular model GAN, the discriminator, the lower module, the discriminator module is with very high accuracy. Correct. But as and when the training goes and goes, the generative model will be penalized. And why this is penalized? Because initially images fed are when we feed the images, the generator network is not aware of. It's the first come of a data which gets into it. So this gets penalized, and this process of penalization is what it helps result in the production of fake images. As a result, the discriminated network at a later stages, when it was with high accuracy initially, declines its accuracy as and when the network gets trained and the generator takes over. So when the generator tries to be stronger, the discriminator goes weaker, and when the discriminator goes weaker, the generator starts becoming more stronger. So that is the advisory effect which these two modules bring in. This discriminative network, which was with a high accuracy initially, would be reduced even to a percentage of 50% accuracy, so that the generator can be enhanced. So this is how this works. Now let's understand the different GAN architectures available. If you have understood the high level architecture, so there are three architectures here: the cyclic GAN, the discriminator GAN, the discovery GAN, I should say, the discovery GAN, disco GAN, and the text to image. The first one, the cycle GAN, what does it do? It's trying to convert an image from a particular style to another. So if you're here, you can see if I feed a GAN an image of a lion, and it could replicate that onto a dog image, or change from one season to another. So here you have an example. When the input was zebra, the photo, it could when I say I need horse photo with the same kind of attributes, it can convert that. Or if I've taken an photograph, I've traveled to a place and I've taken a photograph during the night, and I would see how it looks during day, I can do that using a cyclic GAN. Now getting into the second architecture, this is the discovery GAN, the disco GAN. This concept is where we are trying to understand the connection between objects from cross domain. Say for example, we have different items like handbags and shoes, which we can map. Say for example, if I have a leather bag and I'm trying to use correlate that with the leather shoes, so that's where I'm trying to build the connection between two objects from different domains. I give you another example. If I have a language, a word from language like English, and if I have to translate that into a French or German, that's again a connection. So these are the two different domains where I'm trying to connect object, the word here. I give another example. If I'm trying to, bring in a leather bag, and I would, which is maybe say, or a bag which I'm using in winter, I would also wanted to have a pair of jacket in winter. So it can give me that kind of a correlation. That's where the disco GAN works. The third one is a text to image. As the name goes, we're trying to convert whatever is the text given, it can convert into an image. If you see here, the second image, you have the upper one is the G, the generative network, and the discovery network is what we have below. So here, if you see the little box here, it's a bird. This bird has white, belly. It has white eyebrows, and a dark brown wings. So when I say these one, with we do not go into deep into this. So with this, it tries to create this synthetic image. So this is where it creates a new image with the text facilitator. Understanding all this, let's understand the challenges what GAN faces. There are two things. First one is a vanishing gradient, and the second one is model collapse. The first one, when I say vanishing gradient, this is the discriminative network is too efficient, at the initial stages. And what happens? The model gets stuck here. When it is too efficient, the model gets stuck, and the weight which it would have to upgrade does not happen. That means whatever is the input, the same thing is what I find in the output. There is no difference in the input and output. That's what the vanishing gradient is. So the solution for overcoming these kind of challenges of vanishing gradient in GAN is using appropriate loss function. We've seen some of the loss functions. We'll see in the future sessions what loss functions can be used at different scenarios. Then we have the model collapse. The model collapse is this is where the difficulty at the output layer, the results which results in low quality data. So when the low quality data, more diverse source of data is what is expected. And how can we do that? Generative AI, as we have seen in our previous session, generative AI can create synthetic data, artificially created data. So that's where you can have diverse kind of a data which goes in as a input to overcome the model collapse. With this, I think we come to the end of this session, and I hope you enjoyed this session, and thank you very much, and you have a wonderful rest of the day. See you in the next session. Thank you.